Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Work and Energy. We discuss mainly the part work, then we discuss the questions in work, then energy. Now we are moving on to another aspect of energy, that is transformation of energy. Can energy be changed from one form to the other? Yes, of course, it can be. Actually, whenever we are spending energy, it is getting converted into another form. This conversion of one form of energy into another form is called a transformation of energy. Look at an example of the production of hydroelectricity. In that case, we are actually storing water at a high level dams. So when water is at a high level, it possesses lot of potential energy. When we open the shutter, the water starts flowing down. So it starts moving. When it is moving, which energy it is gaining? Kinetic energy. So the potential energy is getting converted into kinetic energy here. So a transformation takes place here. Now this kinetic energy will make the turbine rotate. So that means it becomes the kinetic energy of the blades of the turbine, and thereby using a generator we can produce electrical energy. Or think about photosynthesis. During photosynthesis, plants capture light energy from the sun and they convert it into chemical energy. So there also conversion from light energy to chemical energy is happening. Or when we are eating food, we are taking the food in the form of chemical energy stored in the starch or glucose. Then it is getting converted into heat energy in our body, or in the form of muscular energy that can be used as the mechanical energy. Another example we can say is very familiar example is fossil fuels. Fossil fuels can be used for working of steam engine. There we are using it in the fossil energy, that is actually a chemical energy stored in the biomass. So that is getting converted into heat energy in a steam engine. What about the car engine? It is converted into mechanical energy there. Or when we are heating it up in the thermoelectric station, then it is getting converted into electrical energy. Whenever energy is spent, it is getting converted into another form. But here comes the significance of law of conservation of energy. What does it state? Energy can neither be created nor be destroyed, but can be converted from one form to the other. The total energy before and after the transformation remains the same. This is law of conservation of energy. Mechanical energy can be of two types, kinetic energy and a potential energy. So when a body is falling freely under the force of gravity, before we drop it, it has no movement. So I am holding it, so that time what is the energy? Suppose this is the object I am holding. This has only potential energy now, because I have lifted it to a height this, so this has potential energy. The moment I release, the potential energy starts decreasing. Now it doesn't have kinetic energy, only it has potential energy. So when I drop it down, then the potential energy got converted into kinetic energy. Just before the reach ground, what is the condition? The kinetic energy is only available, potential energy has become zero. So that is shown here, and now a body is falling freely and it is at position A, that is the top position where it is at rest. Then it has only potential energy, kinetic energy zero, it's not moving. But once it starts moving, it reaches halfway through. So there we can say the total energy will be equal to potential energy plus kinetic energy. So whatever potential energy got converted into kinetic energy, the amount will be equal. Then when it comes down, potential energy becomes zero, but kinetic energy only present for the body. Let us take another example to understand this. So here 5 positions of an object is shown. So initially it is at a height 4 meters. Then it is falling 1 meter it covered, 3 meter above the ground level. Then it again travelled 2 meters. So now only 2 meters above the ground level. Then 1 meter, that is 1 meter above the ground level. Okay. So in each case, whatever be the position, total PE plus KE should remain the same. So if you see from the first case, if it is position A, then the height is at 4 meter. For example, mgh, if I say potential energy is mass into acceleration due to gravity into height from which it is falling. So let's take mass as suppose 20 kg. So what will we get? 20 into g can be taken as 10 here, and height now it is at 4 meters. So we will get 800 joule. That joule is the unit of energy. So potential energy is 800 joule. We know that when the object is at the maximum height, it has only potential energy. Kinetic energy is 0. So total PE plus KE should always be the same. So here it should be 800 plus 0, that is 800 joule. Second situation, it has fallen 1 meter down, that means it is above 3 meters. What will be the potential energy? 20 into 10 into now 3 meters. So we get 600 joule. So 600 plus what we have to add to get here total 800. We need 800 here. So here what should come? 800 minus 600. So it is 200 joule. Third case, again 20 into 10 into 2. So 400 joule. Again total we need 800 joule. So what is missing? 400 joule, that is converted into kinetic energy. So here totally only potential energy is there, no kinetic energy. Then when it decreased to 600, the rest 200 became kinetic energy. Again it covered 1 more meter down, so the potential energy decreased to 400, so the kinetic energy increased to 400. Now we have 20 into 10 into 1, so what it becomes? 200 joule. So again here we should get 800, so how much we have to get here? So 600 joule is the kinetic energy. When it comes to the ground, we know that 20 into 10, but H is 0, so potential energy becomes 0 just above the ground level, but kinetic energy becomes maximum because it has to be 800, so 0 here, so this becomes 800. So we can say that here only kinetic energy is there, here only potential energy is there. Okay, so from this we can understand that energy is getting converted from one form to the other. There is a third parameter which is very closely associated with the work and energy, that is power. See, when I am doing a work, I am taking 1 day to complete that work. Suppose there is a machine which can complete that work in 2 hours. Okay, so I am also doing work, machine also doing work. Whether I do or the machine does, the work is the same. Doesn't make any difference. The same amount of work we both have to do. But here only one difference was there. What was it? I took more time, the machine took less time. So usually when we talk about work, we don't involve time in that. You can take any amount of time to complete that work. That's it. But when we think about the time in which it is finishing, then we call it as power. So who is more powerful? Of course the machine is more powerful because the same work it could finish in 2 hours which I took 1 day. So the rate of doing work, that or the faster it is doing, the more power it has. So rate of doing work is called a power. So we can write the equation P is equal to work done upon time, because we are seeing how much work is done at a particular point of time. So if you see the unit of this, you know that work done, what is the unit? Joule. Right? What is the unit of time? Second. So joule per second, it is otherwise known as watt. So power is also a scalar quantity. So work is a scalar quantity, energy is a scalar quantity, power is also a scalar quantity. We also learned that the amount of work done is equal to the amount of energy we spent. So we can tell energy, power in terms of energy spent also. So in that way, if you see, we can say P is equal to energy upon time. How much energy dissipated or utilized per time, that is the power of that particular body. How can you define 1 watt of power? So 1 watt of power means work should be 1 joule, time should be 1 second. So the power of a body is 1 watt if it is doing 1 joule of work in 1 second. So both these parameters are 1 means here also we get 1. Now what can be used in different ways? If it is a very small quantity, we use the word milliwatt. The unit is milliwatt, that is 1 by 1000 watts, that is 10 to the power of minus 3 watts we can say. Now if you want a higher value, means a big unit, the kilowatt is used. Kilo means what? 1000. So 1000 means 10 to the power of 3 watts. If you want a megawatt, 10 to the power of 6 watts. Gigawatt, 10 to the power of 9 watts. There is one more very popular unit for power, usually we use in engineering, that is horsepower. 1 horsepower is equivalent to 746 watts. When we talk about spending energy, the second is a very small duration. Sometimes we may have to use them in hours, especially electricity and all. So we have another unit for measuring energy, which is a commercial unit. So commercially when we are rating energy, then its a unit is kilowatt hour. That means kilowatt hour is the amount of energy used in 1 hour at the rate of 1000 watts or 1 kilowatt. So 1 kilowatt hour, if you convert 1 kilowatt into 1 hour, 1 kilowatt means what? 1000 watts. And 1 hour, if you convert into SI units, 3600 seconds, 60 into 60, right? So we get 3.6 into 10 to the power of 6 joules, that is the equivalent to 1 kilowatt hour. So this is the relation between SI unit and a commercial unit of energy. So the rest of the questions and some numericals we will discuss in another video. So if you are comfortable with the lessons, please give me a like and also share with your friends. If you have not subscribed, please subscribe to my channel. Thank you for watching Biology My Passion.